Hello, my name is Brian Terbush and I'm the Earthquake and Volcano Program Coordinator for Washington State. Does anyone recognize this mountain? It has a very familiar shape throughout the Cascade volcanoes. Large, tall, symmetrical cone shape, it's by a beautiful lake, glaciated peak. This particular mountain is probably more well known by the shape it took on May 18, 1980, in a very dramatic fashion. This is, in fact, Mount St. Helens, probably Washington's most famous volcano. Washington actually has 5 active volcanoes: Mount Baker, Mount Rainier, Mount Adams, Glacier Peak, and Mount St. Helens. The yellow box on this graphic shows all of Washington's volcanic activity in the past 4,000 years. The red line shows the last 200 years. All of Washington's volcanoes have erupted in the last 200 years except Mount Adams, and they will erupt again. How do we know what will happen when a volcano erupts? We study the past to understand the present. This is done through a process called hazard mapping. When you look at deposits from old volcanic eruptions, we can understand what a future eruption might do. This example is a deposit from Mount Rainier's Osceola mudflow, which happened 5,600 years ago. This deposit is 31 miles downstream from the volcano and is 26 feet thick. This is the volcano hazards map for Mount Rainier created by the United States Geological Survey, or USGS. The near-volcano hazards are shown in pink and are mostly located within Mount Rainier National Park. Downstream hazards are shown in red and yellow and flow down the river valleys. Ash is considered a regional hazard and covers the entire map area. Volcanic ash is tiny pieces of lava fractured by the volcanic explosion. Small amounts of it are a nuisance. Large amounts can actually be dangerous. Volcanic ash is a hazard at all of Washington's volcanoes. It's the most significant hazard at Mount St. Helens and Glacier Peak, which have had significant explosive eruptions covering large areas of the state of Washington. Near the volcano, hazards are tephra, which includes heavy ashfall of 1 foot or more, and ballistics, which are large, hot rocks ejected by the eruption. Also on the volcano's slopes there can be lava flows and domes. On the steep slopes of the volcano, rock falls are common as these domes or flows break apart. Also near the volcano, there can be pyroclastic flows. These are hot avalanches of gas, rocks, and ash that move down the sides of the mountain at high speed. There can also be debris flows in the beginnings of Lahars. These hazards are possible at all Washington volcanoes. Downstream from volcanoes, the most significant hazard is lahars. Lahars are volcanic mudflows. They are a mix of water, ash, and whatever debris the lahar picks up as it flows. These are a very common hazard around the world on any glaciated volcanoes, as the snow can melt during an eruption and lead to a lahar. They're most likely to occur during an eruption, but they can happen in rare cases without one. This picture shows a fresh lahar over snow melt on Mount St. Helens. Lahars can travel miles downstream from the volcanic vent. They spread out when they reach flat areas and river valleys. They're highly destructive and they're a hazard at all Washington volcanoes. They can move bridges, houses, rocks, anything in their path. The areas where lahars have occurred in the past are shown on geologic hazards maps, such as this one from Mount Baker, shown on the right. So how do we tell when a volcano will wake up? Volcanoes are monitored using a series of instruments. Seismic monitoring detects earthquakes and tremors underneath volcanoes, which can indicate that magma is moving within them. Deformation modeling uses GPS and tilt meters to understand which direction the volcano is moving, as it may expand as magma enters or deflate as magma leaves the system. Magma entering a volcano can also be detected in several other ways. Scientists measure the gas coming out of volcanic vents. Scientists also study streams, as magma being near a stream source can affect its chemistry. Sometimes just by looking at a volcano you can detect something different about it that indicates its activity, such as the dome building on the north flank of Mount St. Helens in early 1980. Volcano safety is extremely important at Washington's 5 active volcanoes. Know the alert levels and what they mean. Volcanic activity levels are put out by Cascades Volcano Observatory, and they range from normal to warning as activity increases. As the alert level changes, for safety there may be exclusion zones around the volcano. If a national park or national forest around a volcano is closed, it's for your protection. Most importantly, follow the guidance of volcano experts and local officials. Know the hazards in your own area. You can check the USGS's volcano hazards maps to find out, are you in a Lahar inundation zone? Do you go to school in a Lahar inundation zone? Are the places that you're going to travel in one? When you're near a volcano, understand your hazards. For more information about volcanoes in general and Washington's volcanoes, you can check out a few of the links below. The USGS's Volcano Hazards Program at volcanoes.usgs.gov has information on the volcanic hazards and observatories all over the United States. For information on Washington's volcanoes, go to volcanoes.usgs.gov/observatories/CVO for more updates on all of the volcanoes in the Cascades and their activity. For more details on seismic monitoring at the volcanoes, you can go to the Pacific Northwest Seismic Network's website at pnsn.org. They have details on the recent earthquakes in Washington and Oregon and what's happening under our volcanoes. Thank you for your time. Washington's volcanoes are beautiful. Enjoy them safely.